Can DC-DC converter design reduce output ripple voltage? Have you ever wondered how to achieve a smooth and stable voltage output in your electronic devices? Today, we will explore whether the design of a direct current to direct current converter can help reduce output ripple voltage. Output ripple voltage is the unwanted alternating current variation that appears on the direct current output voltage. This ripple is primarily caused by the switching action within the converter. Reducing this ripple is essential for ensuring stable and noise-free power delivery, especially in sensitive applications like power systems and renewable energy. One of the simplest and most effective ways to reduce output ripple voltage is by adding output capacitors. These capacitors act as local energy storage elements, smoothing out voltage fluctuations. When you use low equivalent series resistance ceramic capacitors, you can significantly improve performance. For example, adding a 22 microfarad capacitor can lower ripple from hundreds of millivolts to tens of millivolts. If you double the capacitance, the ripple can decrease even further. Another effective method is to use an LC filter, which combines an inductor in series with the load and a capacitor at the output. This configuration forms a low-pass filter that effectively attenuates high-frequency switching noise. The inductor limits the rate of current change, while the capacitor smooths the voltage. By carefully selecting the values of inductance and capacitance, you can reduce ripple to just a few millivolts peak to peak. Designing the converter to operate at a higher switching frequency can also help reduce ripple amplitude. When the switching frequency is higher, the energy per switching cycle is smaller, making filtering easier. However, this approach requires careful component selection to manage increased switching losses and electromagnetic interference. Component selection and layout play a vital role in reducing output ripple voltage. Choosing inductors with suitable inductance and current ratings, along with capacitors that have low equivalent series resistance and equivalent series inductance, is crucial. Additionally, a well-designed printed circuit board layout minimizes parasitic inductances and resistances that can worsen ripple. For very sensitive applications, you might consider adding additional filtering techniques. Common mode chokes or pi filters, which combine inductors and capacitors, can further reduce ripple and high-frequency noise. Ferrite beads placed near the output can help suppress high-frequency noise components above the switching frequency range. In practical power electronics design, especially for renewable energy systems where stable direct current voltage is essential, combining these design techniques can lead to effective ripple reduction. Starting with output capacitors and progressing to LC filters or more complex filtering methods allows designers to meet specific ripple voltage requirements efficiently. By carefully selecting the switching frequency, output filtering components, and layout considerations, the design of a direct current to direct current converter can significantly reduce output ripple voltage to levels suitable for sensitive electrical engineering applications.